Good morning, good evening, and good afternoon to everyone joining us from around the world for a very, very special hackathon stream. We are super excited to be bringing you guys the $50,000 San Francisco Agentic Commerce x402 hackathon. We have an incredible lineup of partners from Coinbase, Developer, Google, Cloud, Virtuals, Pairpoint by Vodafone, and so many more. We are very, very excited for you guys to be joining us. We look forward to seeing what you build as well. And it's going to be an incredible day of amazing talks, workshops, and speakers joining us. Before we kick everything off, we're going to be having a great conversation with Jack, the CEO and co-founder of Scale Labs. So we hope you guys look forward to that. It's going to be coming up in a minute. In the meantime, while we wait, make sure you guys head over to DoorHacks. If you are a builder or you're somebody that is interested in joining the hackathon, please head over to the link. It is below in the chat. Jack himself is going to be joining us very, very shortly. And yeah, we're super excited. So do be sure to look out for and stay with us for all of the amazing conversations that is going to be taking part over the coming hours. Remember, x402 as a protocol is very, very early on, and we are so excited to be able to help shape and push forward the future of agentic commerce. And as I was speaking, the one, the only, the beautiful man himself, Mr. Jack O'Halloran. How you doing, friend?
Hey, good. How's it going?
Very good, very good. Are you excited? I'm so excited.
I'm pumped. I feel like, it's some hackathons are, kind of exciting. I think this one's incredibly exciting. I think it's the right time for it. A lot of smart people are signed up, a lot of good people helping. It'll be fun.
100%, 100%. So, Jack, what are you hoping to see built throughout the hackathon?
Here's the thing. I'm looking for creativity. I think one of the biggest challenges we have right now in this whole agent space is, and we talk about x402, we talk about all AP2, we talk about these different standards. It's like, let's see something working, right? And we hear the same kind of handful of use cases that are inspiring. I'm looking for some creativity, someone taking these building blocks and building something we haven't seen before. And so I'm not going to say exactly what. It's just, let's leave a really big design space. And, and I know there's some super sharp people. I've seen the signups. I think we're going to be inspired.
100%. And of course, we are going to be having a multitude of talks from all of our partners who are have their own individual tracks. They're going to be talking about exactly, what they're looking for and how you can really take part in their individual competitions and what they're going to be hoping to see. So, Jack, are you ready for your talk?
I am. Let's see if I can share my screen here real quick. So give me a second to boot this out.
No worries at all.
I never share on StreamYard, so
there's a little button next to the webcam.
Okay.
Yeah, monitor with a plus. But while we're sorting this all out, guys, make sure if you are a builder and you are interested in taking part, you head over to DoorHacks, head over to the Scale x402 Hackathon page, sign up, join Telegram, start building. There are a multitude of prizes up for grabs. And alongside that, something special, Mr. Jack O'Halloran is going to be talking about as well.
All right. So, you ready? Can you see the screen here?
I will throw it up and pull myself down. All right.
All right, let's rock and roll.
Have fun. Guys, enjoy.
Hey, everybody. All right. Really excited to talk today, kick off the hackathon. So I'm going to go through some of the logistics, talk about the prizes, talk a little bit about how you can win. Okay. But let's kick things off here. This is a hackathon about agents. All right. Agents. All right. It's the new developers. We're going to have some fun here. I just want to say, sort of start here and take a step back. Okay. This isn't just another hackathon. There are tons of hackathons. We've done sponsored over 50 of them, and from the early days of Ethereum. So 2018, Scale was there at almost every single Ethereum hackathon for 5 years. Okay, this is one of those moments where we're early, and innovation really truly matters. Okay, and so I think you go out and talk to people still about x402, about agentic commerce, about stablecoin rails combining with agent workflows. There's still a ton of haters out there. There's people that don't believe in this. They don't understand that the power of programmable money and programmable intelligence. And I think hackathons like this are really a foundational moment. And I have some inspiring pictures up here, because I actually think we're at a point where we're going to see some of the next billion-dollar companies be started by teams that are competing this week. And that's not a stretch to say that. When we were doing the early ETH hackathons, almost all the sponsors and a huge chunk of the early competitors all created huge, impactful businesses and projects. So we're here again. So, okay, let's roll into some logistics. Again, this is the San Francisco Agentic Commerce x402 Hackathon, hosted by Scale Labs, as well as Google, Coinbase, Virtuals, Edge and Node, and Pearpoint by Vodafone. It's going to be a 3-day hackathon, okay? Like I said, we've done a lot of these. Why 3 days? Well, 3 days is good because I think if it's 13 days or 30 days, we find a lot of people are waiting to the last 3 days to rock and roll and do things. If it's just 36 hours, if it's just 24 hours, sometimes that's not enough to really build something. Okay. So this is remote. 3 days hopefully gives you enough time to go and make something great, especially you're probably building with AI. There's a lot you can do. We're going to see, I think, a lot of work done in a short period of time. Okay. So submissions will close at midnight Friday. Okay. So I guess that's technically Saturday morning, PST. All right. Judging will happen async. It's going to happen as fast as possible, but these judges all are going to have to look through the submissions and pick winners. Now, there's $50K in total prize value. There's an overall track and then many individual tracks by different sponsors. So very similar to most hackathons, open to developers worldwide. Obviously, depending on your region, please look at Dora Hacks for the details. You can join solo or in teams. You can build something awesome with agents. Okay. And you must, this will follow rules of most hackathons, where if something is closed source, needs to be written during the time of the hackathon. Open source assets can be contributed and pulled in, and different assets can be contributed and pulled in. But the real coding, the real development has to happen during the timeline of competition. All right, some thoughts here on judging criteria. So one, what's your use of AI? That's going to be a big piece here. AI utility. How well do you utilize AI? Commerce realism. How realistic is that we're going to see this out in the world someday? This isn't, we want to see things and see teams that are going to go and really make an impact. And I think the time is now to do that. All right, technical execution. How well do you build? How well is the execution? How polished is it? And what's the shippability? How well do you use partner integration? So huge bonuses for all of these tracks when you thread multiple partners together. Okay. Presentation and demo. At the end, you're going to have to summarize this up into a video and build a demo. And that's important as well. It's not the most important thing, but let me tell you, it helps. Sometimes some of the best projects don't get the same visibility in hackathons because they don't have a crisp demo. So keep it simple. Say what you want to say, what you're doing really clearly at the beginning. That's probably the best advice I can give you. Teams I see that do well are really overtly clear about what they're doing at the beginning of the demo, so the judge knows what you're building, and then you can show them. Okay. All right, creativity. This is an interesting time. Like I said, we're very early, but we're not late. We're at this I think sweet spot, and creativity is going to be rewarded. Okay. All right, so there's an overall track winner. There'll be a first and second place, 2,000 USDC plus 5,000 Google credits plus 2,500 in scale credits, and then 1,000, 5,000, 2,500 below that for second. Again, this is what the judges are going to perceive as the best end-to-end novel project or use case. Go for it. It's going to be fun. So next one is going to be Google. So use of Google AP2. All right. If you don't know about AP2, please check it out. Open source standard designed by Google. Over 100 partners collaborated to bring this together. That enables secure, authorized, interoperable transactions for AI agents. Okay. So you'll learn more about this during Google's presentation later today. Nalin Mittal will be judging. He's a product manager on the Google Cloud team in their Web3 group. Really sharp guy, knows Web3 space and agent space cold. Excited to see what people build in this track. 2,000 USDC and 5,000 Google Cloud credits for first place, second place, 1,000, 5,000. For best use of AP2 authorization plus settlement inside an agent workflow. This track is about proving clean or usable patterns, intent, authorization, settlement, receipt. Okay, Coinbase Developer Platform, CDP. Okay, so utilizing x402, CDP Wallet, Agent Kit. CDP, I think, is one of the best product groups out there in the space. They're making amazing tools, really sharp team. And hey, these are the authors or the co-creators of x402. That are within the Coinbase Developer Platform team. So we're going to hear from Kevin later today. Kevin will be judging. He's a GTM lead at CDP. They'll be giving 2,000 USDC plus 5,000 Google credits and 1,000 USDC to build on-demand. So go use Coinbase, use x402, use CDP wallets, use Agent Kit, use their products. You can learn more about it later today. Okay. Scale, another sponsor. And so you can actually build and deploy on the Scale on Base blockchain. Scale is a blockchain that has an authority component that to date has been built just on the Ethereum mainnet, and then it runs the Scale network on top of it. It's a bit of a layer 1, layer 2 hybrid. It has layer 1 capabilities, layer 1 security model, but advanced security because it's integrated and connected into the Ethereum network. Now, that same set of logic or smart contracts now has been deployed on the Base chain. And then on top of that, there's a Scale chain that's running. And so it has really seamless interoperability with Base, a revenue share component back to Base in a decentralized manner. Scale's a decentralized network. And so we want to see you go build on Scale, whether it be a Scale testnet, Scale mainnet, or Scale on Base. But we'd also love to see you be able to build using Byte Protocol. What's Byte Protocol? Byte Protocol is an encryption and privacy protocol. Okay, so that you can actually hide balances. I can do conditional transactions and have if-then moments happening on chain that my agent can like set up to make sure that they're ready to enact when data patterns meet with how conditions they want to see for a transaction to execute. Okay, so check out Byte, and also. We like to check out the barista test. So if your agent's buying something for you, if they're buying a cup of coffee, do you want the barista to know how much money you have? So you can actually hide those balances and quantities sent using Byte Protocol, all within EVM with zero gas fees, instant finality. There's no gas fees. There are things called Scale credits. Okay. So Scale's historically been one of the top gaming chains with over 2 billion on-chain transactions. And I got to tell you that it was the perfect training ground for agents. Okay. So this is a battle-tested chain, battle-tested EVM code, and you run Scale consensus, which has instant finality. Love for you to check this out. Excited to see what you can build. Sawyer Cutler, Manuel Barbas will be judging. 2,000 USDC plus 2,500 scale credits for the winner. Second place, 1,000 USDC plus 2,500 scale credits. All right. Okay. One other thing I'm announcing, we're going to give away, we're allocating 250,000 in scale credits post hackathon. So you need to deploy to scale during the hackathon. And then it will be allocated based off of essentially viability for moving forward. So if you have a project, you really want to launch something, we're here to support you. Get in touch with our team. This is here to not just have a great hackathon, but make sure we have a really strong follow-on. Okay. All right, Virtuals. Virtuals is an amazing group here, amazing protocol, building a society of AI agents with Agent Commerce Protocol. So go build on Agent Commerce Protocol. They're doing some really cool stuff. I think it's interesting to think about how Virtuals could be connected to scale, and then Coinbase CDP products, and then an x402 and Google AP2. Like, it'll be interesting to see someone wrap all these things together, and there's a lot of cool stuff you could do. First place, 2,000 USDC. Second place, 1,000 USDC. They will tell you more during their talk later today. All right, so one last, our workshop schedule. In just a few minutes, we will be rolling into, these times are Eastern, so Pacific 9:05, 12:05 Eastern, 12:30 to 12:59, workshop 2, Google Cloud, 1 to 1:30, the Virtuals workshop, 1:30 to 1:59, Coinbase CDP workshop. So we welcome you to come check out these workshops. This is where, hey, if you're looking to win, which I gotta say, the prizes are good for winning, but probably the most valuable thing is being able to say, hey, I went and won the Google track, I won the Coinbase track, I won the scale track, I won the Virtuals track, or I won the overall track. Always great for fundraising, always good for building momentum for your project. And a really great way to win is to go and listen to these workshops, learn, understand what these are the people that are going to be judging you later, understand what they're looking for. All right. So there we go, Ben. What do you think? I think people are ready to go now? Ooh, I can't hear you, Ben.
There we go. Yes, people are definitely ready. We're excited, to kick this all off, and as we do so, as Jack said, make sure you guys stick around, listen to the workshops, because they're going to give some incredible insight, not only into them as individuals and the history of the technology that these tracks are based off, but how to win. And speaking of how to win, we are going to be having Mr. Sawyer Cutler jump in for our first workshop with regards to scale and byte. What do you think, Jack? How important do you think is for the people that aren't aware of what byte is? How important do you think byte's going to be right now when we are building new technologies?
Yeah, well, I'll just say threshold encryption is a very, very cool tech. Okay, so I think people know about FHE, fully homomorphic encryption. They know about other encryption models. The cool thing about threshold encryption is that it's incredibly lightweight. It's incredibly efficient. Okay. So the cost of execution, the speed of execution is just so much faster with such lower costs. And so Scale, just from day one, has been using threshold encryption. We use BLS, and that's threaded into a lot of the things we do across the Scale protocol. And so I think it's going to be interesting to see how people leverage privacy and agents. So they're both two new fields, right? So even today, even if I'm not an agent, if I send Ben money here, if I send him 10 USDC, do I want him to see my entire history that I've in my, of transactions, or what my account balances are? No, you don't want to. Okay. Like, you want to keep certain things private. And I think it becomes even more important in the agentic world as our agents are out doing who knows, what on our behalf. Privacy is going to be a key part of that. So two kind of frontier spaces coming together today. And I think, again, I've looked at the signups here. We have some really smart builders. We have some smart teams, and we're going to, I think, see some cool stuff.
100%. Well, Jack, thank you so much for taking the time. I really appreciate it. We'll let you go, and we'll see you
we'll see you tomorrow. Our weekly show.
Weekly show tomorrow.
INTT.
Yes, 100%, 100%. Talking the fun stuff.
Yeah.
But appreciate it, Jack. Any final words before I bring up Sawyer?
I just say good luck. Have some fun. Build something cool. Be bold. Okay. I feel like the winners are the people that do something bold and creative. And hey, even if it's not bold and creative, put your best out there. I think a lot of execution is really critical too. But hey, have fun. That's what we're doing this for. Okay.
100%. Doesn't matter if you're a well-established builder or somebody that's new, just using the AI to help try and bring an idea to life. It's all about just having fun, learning, and making friends along the way.
Yes, sir.
Yes, sir. All right, Jack, thank you so much. We are going to run to a quick little break, and then we'll kick things off with Mr. Sawyer. Actually, we're not going to run to a break.
Okay, I'm going to drop
Bye, Jack.
See you later.
Thanks, Jack. Bye. And we're going to jump into our first workshop of the day. Hello, Sawyer.
Hey.
How you doing?
Jinx.
Jinx. Yo, me a soda. Doing well. Yourself?
Oh man, I've had a fun 48 hours. For those that don't know, preparing for the technical side of a hackathon is very fun, especially when you're launching something brand new as part of it, because functionally nothing ever works until you need it. So I kid you not, the demo I'm about to show, I got working 4 minutes ago. So that was my last 40 hours.
Very nice.
But I'm very excited because it's something that I've never personally seen on a blockchain. I wish it was more financial. I had a swap working and then, well, it broke, but we still got some cool stuff. So anyways, I'm excited.
100%. Well, let's stop talking. Let's start showing. All right. Let us jump into the scale workshop. Sawyer, do you have any materials ready to share?
Yes. Do I need to share my screen the whole time? Make your life easy.
Yes.
Okay. I will share this screen then.
Amazing. All right. Well, I'm going to jump on down. Sawyer, take it away.
Awesome. Okay. Welcome, everybody. I'm actually going to go to here, and we're actually going to start here. All right. Welcome, everybody, to the Scale Workshop. Today, we're going to be focusing on encrypted transactions on Scale. This is something that I am really excited about. I think for a long time, the blockchain landscape has been a little bit stagnated. And I think this is a feature that we feel is really taking things in a direction that the world of on-chain commerce and agents and everything is going to need. And so we're very excited for you guys to get hacking on it this week. So without further ado, quick introduction. My name is Sawyer. I run Scale's developer success team. I help builders build. That's basically my primary job. So I'm a builder myself. My background is in software engineering. I've spent a number of years now in solutions engineering and DevRel and all these good things. And I'm just really excited to showcase this today. So before I do that, I'm sure Jack gave some really good information regarding Scale, but I have no idea who stuck around versus who's new. So I'm going to start off by giving a quick introduction to Scale. If you want to follow along with me, you can actually go to docs.scale.space. We have a very nice documentation portal with pretty much everything you all need. But basically, let's start with what is Scale. Scale is a blockchain network. Okay, Scale is actually multi-chain by default, although for this hackathon, we're going to be focusing primarily on one chain. And this multi-chain design has allowed us to do a number of things over the years that are very unique and different. The first one that we're most well known for is the gasless aspect, right? So being able to do gasless or zero gas fee transactions is something we've been able to do for a very long time. If you're interested in learning more about how that works, you can actually head over to the developer section. You can learn all about zero gas fee and gasless chain. So again, it's all the docs here. Now, the way this has actually kind of worked is through this multi-chain network. So The multi-chain network is created via a application called Scale Manager. Scale Manager is deployed on another blockchain. So originally, about 5 years ago and change, it was deployed on the Ethereum blockchain, so Ethereum mainnet. And then a few months ago, we deployed it on top of the base layer 2 chain as well, which is where this hackathon is going to be targeted. And so what Scale Manager allows is the creation of new scale chains. And scale chains are, I call them mini Ethereums with superpowers. They've got a lot of really cool stuff. They're really fast, really powerful. They've got some privacy aspects. They've got this encryption stuff that we're going to talk about, et cetera, et cetera, et cetera. List goes on and on. Now, the encryption part is really critical. And you may say, well, hey, just get to the workshop. I'll get there in a second, I promise. I want to call out a few pieces on our documentation here down in the bottom left of the concepts page. This is where you can really deep dive into how the encryption actually happens. So if you're into understanding what is going on behind the scenes, that's your deep dive written by our incredible engineering team full of world-class physicists and mathematicians. At a very high level, right, let's talk about what is threshold cryptography and why is it so relevant here. Scale is not a rollup, okay? So Scale does not push transactions back to the parent chain, aka it doesn't push transactions back to base or to Ethereum. Scale actually does, Scale has the transactions running directly on the Scale chain because there's validators in the network. Now, each of these validators has a share of a private key, okay, or a secret. When the supermajority, aka greater than 2/3, aka like 3 of 4 or 11 of 16 or 67 of 100, agree on something and they all sign something as proof, that will then generate a valid signature, which can then be utilized to actually move the information forward and execute it, okay? So what this means for the Scale chain is your consensus is already using this, which is great. This stuff has been in production for over 5 years. But what's new is us bringing this to the forefront as Byte Protocol. So Byte Protocol stands for Blockchain Integrated Threshold Encryption. Okay, so we've taken this threshold encryption that has already existed on the Scale chain, and we have now created the functionality for you to now encrypt data in transactions and have them natively executed as part of the blockchain. Okay, at a very, very high level, this runs through the consensus of the chain, which is very different than most privacy layers, applications, and projects. Most projects run this as a separate third-party chain. You're trusting a very small subset of nodes, and you don't really get that much quote-unquote security because you're just basically saying, trust me to that other entity. In this case, you're trusting the same validator nodes that are actually running consensus. So right now, Byte is available in 2 parts. We call them encrypted transactions, or previously Byte Phase 1, and conditional transactions, which was previously Byte Phase 2. Today, I'm going to be showing you the second one, conditional transactions, since that's where the hackathon is. I will have a demo that I'll be posting live probably later today or tomorrow with the Phase 1 piece for you. But that part is, like I said, a little bit broken from if you heard the intro. Apologies for that. So Byte Phase 1, very simple. Kills MEV at the root, okay? It does threshold decryption during consensus. So what does that mean? Alice wants to send 10 USDC to Bob, or Alice wants to do a swap. Alice's agent wants to do a position in an AMM, whatever it may be. Before Alice sends that transaction to the chain, she actually, she goes ahead and she basically encrypts that locally using the BLS shared public key for the Scale chain, encrypts that data, sends it to the blockchain, and then after consensus, before execution, it is then decrypted by the supermajority of the validator nodes and executed properly. And so what that means is nobody, Charlie, et cetera, cannot see that transaction until after it's executed. So whether you're building anything related to finance, DeFi, really high performant agentic actions, Byte Phase 1 is great. Additionally, it's really nice because it doesn't require any solidity changes. You just encrypt it off chain and then it gets sent kind of as a private encrypted transaction in one pool. Phase 2 is where we're actually really getting excited. right? This is the conditional transactions. Conditional transactions are really simple, actually. You have a condition that you want some encrypted data to be executed on. So example, you have an AMM pool. You want to create a limit order. When the price of Bitcoin hits X, you want to sell or buy or do whatever, right? Now, on most chains, that happens either off-chain or it's done on-chain, and you just get kind of crushed in terms of MEV and your strategies leaked. This allows it to be fully private until after it's actually executed, and the chain takes care of the automation for you. Enough talking. Let's showcase this, right? That's what you guys actually probably came for. So I'm going to actually start out with wherever I put it, here it is. I'm going to start out with a pretty basic, pretty basic example. I'm going to run this side by side so you guys can kind of watch with me. So this is a fantastic demo that actually our engineering team put together. Shout out Oleg and Dima D2 and a bunch of others who supported here. This one is pretty, we'll call it pretty simple from a kind of getting started perspective. So what we're going to do is we're going to have a bunch of numbers that we're basically going to encrypt off-chain using the encrypt message function in Byte. And then those are going to be sent on-chain and stored on-chain encrypted. And then we're going to generate some unencrypted ones on-chain, and we're going to basically check who won, right? Who has the bigger sum of numbers, the encrypted set or the decrypted set, or the public set, sorry. So pretty simple. We're going to run this. If you actually want to follow along, what I will do is you can go to, sorry, let me pull this up for you. Maybe you can actually go here if you'd like. It's under the Great Axios Scale CTX's Foundry Starter, and you can actually clone this and run it. It's the exact same thing I'm running here. It's all public, but you can see what's actually going on is we have a bunch of transactions coming in, and these are actually the submission of encrypted numbers to the contract. So all of these transactions right now are actually encrypted data being sent to the contract. We have no idea what this is. There is no way to directly decrypt this. And now where we can see is, here we go, these values coming in, which it's probably going to look pretty much the same because this is not a verified contract right now. Apologies. You can see these are a lot smaller. It's actually the exact same. It's the exact same data, just one's encrypted and one isn't. So you can see this is just a basic number here coming in, nothing really too special. Now, where this gets really, really powerful is the CTX, okay? So the conditional transaction, again, is something that actually gets executed on the next block, okay? It gets executed at the start of the next block. So if we're thinking about this flow, we have a bunch of data submitted, and it could be stored on chain theoretically indefinitely, right? The condition is actually going to get triggered by another transaction, right? Because we need to know something is happening. And so in this case, it's based on checking to see if the decrypt and execute function is executed. When that occurs, that is actually doing something called submit CTX, which I will show you the code here. We'll go here, run game.ts. What we can actually see is right here, we are submitting the encrypted numbers, okay, one by one. And then what we're doing is we're submitting the plain text numbers. Now what we're doing is we're calling this, where did I go? There it is, contract.decrypt and execute, okay? And so what this does, if I go out of here and I go into the game, what this actually does, and we can walk through this together, is we can see we're storing the plain text numbers and the encrypted numbers on chain, okay? And these are fairly basic. We're just adding numbers to an array. Now the decrypt and execute is where things get really interesting, okay? What we're doing is we're actually basically taking all of this information and we're aggregating it together. And what we're then doing is we're triggering, using this precompiled smart contract, the submission of the CTX. So again, the submission of the CTX is where anybody can actually create that transaction, which will then call the on-decrypt function on callback. So this gets a little bit confusing, so I'm going to use an analogy. If you're familiar with Chainlink, Chainlink runs on a callback system, okay? So the way Chainlink works is you make some Oracle request, and that Oracle request gets sent out, and then in the next block or some block thereafter, they actually post what's called a callback, and the callback is somebody else actually making that transaction for you, and that's usually going to be their service. This is very similar, okay? Sorry, I was just notified that my screen is frozen. Oh, I apologize. You guys can't see that. That's embarrassing. One moment. Thank you to Dima D3 for the shout out. Here we go. I apologize, guys. For everybody at home, sincere apologies. That is fixed now. Let me run back through that really quick for you, because you were supposed to be seeing a lot of stuff. My apologies. TLDR, we've got a smart contract, we've got plain text, and we've got encrypted array, okay? These are values that we are then pushing from the client side, okay? Thank you, Topor. When we call the decrypt and execute, this schedules a transaction to be executed on the next block at the start of it. So you're never going to run behind people in the next block. You're always going to run at the very top of it. And that is done via a callback. And so the reason that we have this native gas transfer here is because we're actually filling up what's called an ephemeral wallet, which is used one time in the next block to execute that transaction on your behalf. So that wallet is actually the one that calls on decrypt, and that's managed all by the blockchain for you. So this is where scale gets really, really powerful, is you don't have to worry about any of that, okay? That's all taken care of for you. All you have to do is supply some encrypted information and then, well, trigger something that's gonna create a condition and a trigger. So moving forward now, let's talk about how this can actually work in, kind of in practice in UI, right? How does it look for people, right? Obviously, this hackathon is gonna be very focused on agents. And so I expect we're gonna see a lot of teams focusing on how's this gonna work with, an agent making this call just via code. But I think for a developer trying to wrap your head around this, it's great to have this understanding of what does this actually look like in practice? And the answer is, it doesn't really look that different, which is kind of nice, okay? This is a really terrible vibe coded UI. I apologize. We can thank Claude Code for it. But this is a super simple application and game that I'm just going to kind of walk you through here, which is going to go through the same exact process. So the first step here is I am going to pick rock, paper, or scissors, and our little mountain here is representing rock. So I don't know, we'll pick scissors this time, and we're going to wager some SKL. So we'll wager 10 SKL. This is all local testnet, not real gambling. We're going to go ahead and make the approval. Please note that none of these transactions that I'm sending right now are actually being encrypted with byte phase 1, and that's on purpose. I wanted you to be able to see the transaction data coming in, so you can kind of have an understanding of what's happening where in what step. But we could absolutely encrypt all of this with byte phase 1, and I'll actually show you that in a second, what the raw byte code looks like going in. So we're going to go ahead and sign this. And what's going to happen over here on the right side, we can see the approve just came in, and then immediately after, we're going to see the token transfer, okay? And so this is me transferring 10 SKL into the contract, but the interesting part is the move that I made is fully encrypted. So even though you guys know, because you're obviously watching my screen, if you attempted to read my move, it would come back just kind of garbled, no way to tell, right? It's encrypted. So now we're going to go ahead, and that was game ID 2. And so we're going to go ahead and let's actually switch wallets here. This computer doesn't have one. I apologize. We'll just use this one. Sorry, I've been jumbling browsers and machines. And we'll go ahead and approve this again. So I'm obviously just playing against myself right now. But we have a different move. We can see the bytecode we can see the bytecode here has changed quite a bit, right? So totally different. And now if we go back here and watch, we can see another token transfer. But wait, we can also see 2 token transfers. Why is that? And we also see value. So let's step back through this, right? The second transaction here sent the 10SK element, right, to the contract, but it also sent some of this native gas token, right? In this case, it's S fuel, could be credits. Again, the zero gas fee is a abstraction over the top of what gas is. We use a gas token natively to keep compatibility with the EVM, but it has no monetary value. So in this case, we're sending this gas and it's being directed to that ephemeral address, which again is going to be used to execute the CTX. But now what you'll notice is I only submitted 4 transactions, 2 approvals and create game and join game. But we have a 5th transaction. And this 5th transaction actually transferred 20 SK. So what just happened? The answer is OnDecrypt got called, right? The CTX actually triggered automatically. When I joined the game as the second player, what happened was it recognized that both players were in, which we can actually go, let's go pull this back over here. And we can do, where is it? Let's pull this back up for you. CTX is 2. CD rock, paper, scissors, contracts, and rock, paper, scissors. Nice. Let's go ahead and pull this up for you and we can take a peek. So what happened? We created the game, that was a transaction. And again, we can see the ERC20 movement. We can see all the game state was set. Join game is where things get really interesting. What happened? Well, we double check that we have 2 players. We double check that we have the right CTX gas payment, which is needed. We transfer those in. And then this is where what gets really fun. We submit the decrypt CTX, which is an internal function here. What is this actually doing? This is actually creating the necessary information to call the precompile to actually trigger that CTX. And then this precompile, which I can show you over here. Thank you so much to Dima D2 for helping me get this right. This is definitely a little bit complicated, working on making it a little bit easier. But you can see here, we actually call this submit CTX, which similar to our previous example, right? If I go all the way down here to call precompile, we are going to see, where's my precompile contract? We're going to see that call here, which precompile contract is, oh, I'm missing it actually. Where is the 0x1b? It's in here. Maybe he just hit it better than I can find it. But essentially, what's happening is this is triggering that next the transaction on the next block. So I digress. Let me pause there and recap this for you, and then I want to show you one last thing before we close out. What did we just do? We created a condition, right? In this case, the condition was we need 2 players who have both submitted their tokens and have both submitted an encrypted move. When all of those conditions were met, we then create a CTX, right, transaction, which is then executed on the next block automatically. So lots of opportunity to think about how this can go. But we'll be around, all throughout this hackathon, helping you guys build. Please note that this is all being done specifically on our hackathon chain. So this is in a sandbox environment. If you go to docs.scale.space and you go to this hackathon page, you'll see all the information you need is right here. The RPC, the block Scout Explorer, the chain ID. If you need gas tokens or USDC, join us in Telegram. That should all be in the Dora Hacks page. And you can just ping us and we'll get you some gas tokens. That way we can just send you a whole bunch. Our faucets are limited by default anyways. If you're using x402, we have our incredible partner Kabaru, who's available and up and running. If you have any issues, just let us know. Our USDC is fully compatible with x402 there as well. And because this chain is fully EVM compatible, you can use the other partners on top of it. You can use the embedded wallets. You can use you can use all of the other partners right on top. So thank you so much. Sorry that you missed my screen for like 10 minutes there, Mr. Falco, or maybe next time you'll tell me in my ear, but it's all good. Excited to help everybody build here. And yeah, best of luck. And if you need anything, come contact us at Telegram.
100%. So thank you very much for joining us. Whilst we are, we're going to be jumping now into our next workshop. Please join me in welcoming our special guest from Google. Hello, Mr. Gotham. I really hope I didn't butcher your name. I apologize.
All good. It's pronounced Gotham. Cool. I'm very excited to be here.
100%.
Cool.
We're excited to have you. Why don't you give the people a little introduction about yourself before we jump into your workshop?
Sure. So, hey, I'm Gotham. I work at Google, currently on our Google Cloud Web3 team, where the team has kind of collaborated with Coinbase to introduce the x402 extension to our 808 protocol. I want to give a bit of a higher level overview of what all this means and kind of like how this works all together. So I'll actually be going over not just A2A, but also AP2 and x402 extension and how they all kind of facilitate together for transactions between multiple agent parties. So let me see if I can share my screen real quick.
Yeah, I'll jump down, bring a screen up, and let you kick it away.
All right.
Well, have fun.
Yep. Oh, perfect. Okay. Cool. So basically, to start, we'll dive into what like A2A is, right, and why it's needed. So let's say you want to build a like AI travel agent. Ideally, you want to connect with that, like with a separate flight agent, right, and a hotel agent, or like an activity coordinator to kind of fulfill your entire travel needs. And you don't want to build all of these individual agents yourself. And there are already separate agents that exist, roaming out there to connect with. So the world kind of needs a standardized way for all of these agents to communicate and collaborate on these tasks, right? And that's kind of where the A2A protocol is and where it comes from, right? So this is sort of an open standard designed to be a common language for these AI agents. So while most frameworks like say, AI agent, like agent developer or LangChain or Career AI have concepts of sub-agents or multi-agent systems, A2A allows for these agents to kind of communicate with a remote third-party agent, right? So all of these agents could be different tech stacks or different frameworks, but still be able to collaborate on the same task. And then A2A facilitates communication between a client agent and a remote server agent. So the client agent is responsible for formulating communication requests to connected agents, while the remote agent is responsible for acting upon those requests, providing the correct information or completing the requested service. A2A is also fully open source and open governance protocol. It was created by Google in 2025 in April of last year and was donated to the Linux Foundation in June. So I'll go over a bit of the capabilities over here real quick, but basically the core capabilities are it's dynamically discoverable. So agents can dynamically discover and connect with each other through registries, including on-chain ones like, ERC 8004, which we'll get into later. There's standard collaboration, so they can agree on tasks and share content between each other. There's long-running instance processes, so they can handle long processes and update each other while they're ongoing. And then there's like enterprise-grade security, so everything happens within each agent opaquely, right? So they're with each other. So the protocol is only a bridge and doesn't expose any inner workings. So I think a common question we get is like, what's kind of the difference between A2A and MCP? To be truthful, these are complementary protocols, not competing ones, right? So MCP is about how an agent connects to tools, API resources prompts, right? So it's a standardized way of agents to perform functioning calling or executing tasks on the user's behalf. And then A2A is on how agents communicate between each other. So I have an example. Agents in this system, like this, I guess, sophisticated system, like agents might use both for example, right? So we have two different agents with two different LLMs on different hosting services that can actually connect to different MCP servers. But the bridge of all that, with A2A to work together, right? So you can see there. So I guess now I'll talk about how A2A works, and then the communication structure between these agents, and then we'll get to x402 there. So the client agent, the one the user interacts with, identifies the remote agent it wants to connect to and send requests. And sometimes something to note actually is that given agents can act, as both a client and a remote agent, depending on the context, actually. With agent discovery, how does agent A find agent B? One of the endpoints is discoverable. So agent B presents an agent card, which we'll get into in the next slide. Think of it as like a digital business card. So it's kind of like a standard JSON file found in well-known URL. There's like an agent domain. The card kind of tells agent A everything it needs to know, like its name, its service URL, capabilities, scales, and it can also list supported extensions like x402. So as you can see, yep, there's kind of an example of what this agent card looks like. So the card would obviously have like a name, description, the URL, sort of skills and capabilities. So agent A knows if it wants to engage in this with the other agent to complete a task. The card serves as sort of a discoverable URI for agents to connect to. And the agent card also presents information such as like streaming capabilities and supported extensions, right? So now I'm going to go over like the basic interaction. So for the basic interaction, basically methods and data structures are defined in A2A spec, right? So agents communicate through HTTP over standard protocols like JSON RPC or JRPC, right? The message object includes kind of like a role and with user versus agents and parts. So the actual content, which can be text files or structured JSON, right? Let's see if I can go through here. And if the request takes so you obviously we have like this message object over here, right? As I said, like it includes like a role, so the user versus an agent and parts, so the actual content. So that could be like text files, JSON, and then you've also got like the tasks specifically, right? So the task object. So if a request takes time, the remote agent responds with a task ID or status, so submitted working, inputs required or whatever is completed or failed. And then we also have like an artifact part over here, right? So once the task is done, the remote agent responds with an artifact, which is the final result or receipt. And then, of course, there's also real-time updates. So a client can actually pull for updates or listen through server sent event SSE for better user experience. And then for the basic interactions, so the A2A SDK provides agent executor class, so which is available in a Python library, which I'll share later, and handles generic protocol pieces, so the HTTP, JSON, RPC conversions, and event management. So you can focus on the agent logic rather than the communication protocol, essentially. With this kind of suggested stack, the one you could use to create an agent, you could use this to be able to connect with like the A2A protocol. We have an underlying agent framework, which could be anything. But yeah, in this example, we can use like ADK. We have ADK over here. Agents connect to other services with MCP servers, and this can be hosted on different hosting sites like Vertex AI agent, which is one of what we use often. Is where we often use to host these, and then all of these can be wrapped within A2A to allow like direct communication for the protocol. So that kind of wraps up a quick run through of A2A. There's additional documentation that deep dives into other sections and a couple of sample libraries as well to get it up and running and understanding how you can build agents that are able to communicate with A2A. So I definitely recommend screenshotting this QR code if you can. Slides will probably be shared later. And then also some code samples over here too. So now I'm going to quickly also go through, take it a step further into the AP2 extension, and take a moment to explain what this extension is. So additionally, on top of the A2A spec, we can also have custom specs written known as extensions, which can indicate additional skills or capabilities that an agent has that can be presented in their agent card. So any connecting agent knows that these specs and additional capabilities are supported, and one of those is the AP2 extension, right, which stands for the Agent Payment Protocol, Agent Payment Protocol. So it's a way for agents to securely transact between each other. And with AI agents, compressing the product, right, discovery. So with A2A opening a world of new agents to connect with the work together, the task starts to become a little bit more complicated and potentially kind of requiring payments along the way for tasks to be completed, which kind of opens up a trust and security question that comes along with how we can make sure all of these can be done securely, right? And so imagine being able to describe what you want in an AI agent, and it can find and purchase that on your own behalf without having to do all the research. And it's that and with this, like, your agent can be able to make the best decision for you. But these kind of issues with payments now, right? How like the entire kind of global payment infrastructure was built for humans and not autonomous agents. But today, payment systems assume that there are always, humans in the loop directly clicking, buying, supplying their card information. When autonomous agents initiate a payment, it's kind of breaks that assumption, right? And raises a lot of questions about the trust of the system. So how can we provide what a user gave in an agent specific authority to make a particular purchase? And how can a merchant be sure that this agent request is accurate and true to when a user is wanting, and not some hallucination from the agent? And if there's fraud involved, right, who's accountable, right? So at what point did fraud originate and the liability in the situation, right? So that's why Google introduced the AP2 protocol, so the Agentic Payment Protocol. So it's an open source protocol, as well as designed to create secure, trusted foundations for future AI-driven payments. It's compatible with existing standards such as A2A, MCP, and it allows you to build upon existing work to create secure, reliable frameworks for this. And again, core concepts are that it's open, interoperable. We want to foster a competitive environment where everyone can innovate and build on this, right? It's user controlled and privacy by design. So we use verifiable intents and verifiable credentials, not inferred actions here. So it's clear transaction. We're trying to provide accountability and visibility to the entire chain of decisions that was made before the purchase was completed. And we also want this to be global and future proof. So we want to support the classic pool of payments like basic cards, but also additionally forms of payments such as like digital assets over like, x402 or sort of, additionally new introduced payment rails as well. So how does AP2 achieve this? So it's kind of like, so here's an example of like the architecture of where an actor has a specific job. Note that this is just like, one of the setups that's possible, but the flow can be changed for the best use case. But in this flow, there's like a shopping agent, right? And then in this agent, the AI user is talking to, it can be, say, like Gemini, and can understand requests. It can discover products and assemble carts. There's like a merchant endpoint. So this is an agent or maybe even an MCP server that lives on the merchant side, and it's able to kind of showcase products and negotiate cart prices and details with the shopping agent. So there's a credential provider. So this is kind of a key point of security, right? it's a digital wallet in the sense that it manages user payments and methods and securely handles that payment credentials. So that way your shopping agent is never actually touching private or personal information. And then there's a merchant payment processor, which handles the verifiable credentials and payment credentials from that payment processor. So, and all of this will be running on a network or an issuer that could be different payment rails, right? And this kind of core concept, core concept. So here's like a cart mandate for which captures the user's final explicit authorization. So for which we want to purchase and at a specific price that it was agreed by the merchant, right? There's also an intent mandate for scenarios where a human might not be in the loop to authorize maybe the cart mandate, but the intent is to mandate is clear enough and has been kind of verified by the user that the payment flow allows to proceed because the intent can be verified and trusted. So then there's finally a payment mandate, which kind of ties these all together and creates a separate credential for the payment network to prove to payment networks that the user approves these payments and gives the payment network permission to release these funds and merchant agents. So now, actually, feel free to take a screenshot of this. So this just takes us to the GitHub repo for AP2 documentation. But switching gears, now we can like kind of talk about the overall consensus here with x402, right? So with the x402 extension, kind of a quick flow, right? So I want to walk through some of the different objects that were kind of introduced with AP2, which we'll go over more in like the code review. But basically, this is kind of like the state flow where like a server requires a payment. Payment is rejected. Client rejects the payment. If a client creates the payload, payment is submitted, and then it checks for verification whether the payment has failed or the payment has completed, which was like added here. But the client agent is able to kind of iterate and support these types and select which wallet or what is supported methods desired for the client here. And it's also able to fulfill, the requests by creating a signed payment payload. So I think this is a good example actually of this where, for a single flow, like a standalone flow, right? Client would be able to request a message and the merchant agent would respond with x402 payment required and then respond in the input required for the state of this task. So these like x402 payments required objects that, which were brought up over here, right? That the client is able to kind of iterate through and support these types here. So you select which wallet and what support method is desired, and it's able to kind of fulfill these requests by creating a signed payment, with the task ID, and then sending it kind of like back and forth with the merchant, and the merchant can take that ID verification with the signed payment payload, and then basically correct the amount if it's valid. And the merchant agent will process this request and then use x402 facilitator to post and settle these requests when it finally responds with the client agent with the settlement responses. And then we'll talk about like the embedded flow. So another step further with these objects can be to package and embed inside of AP2. So not only do you have signed payment payloads, but these can also be wrapped inside of intents and intent mandates and cert mandates, right? So there's a full flow of a trust from as soon as the client agent indicates that it is a specific intent from a user all the way through signing on behalf of the user's wallet to completing the final transaction and having the merchant settle it. So there's like auditability trail throughout the entire flow. I have a quick demo real quick of like how this flow would work. So let's see if I can run this real quick. Let's see. There you go. So hopefully folks can see the screen. So, kind of a quick flow, kind of showing MetaMask wallet being used as a verifiable client provider and signing the intents and mandating and setting the x402 transaction. There's actually some code samples I can share of this. So right now, setting up the MetaMask, has the USDC selects the client agent, and then, yep, says it wants to buy some air air mattresses. Yeah, Air Maxes. So we'll kind of go through this flow over here, right? And then, yep, it will list the remote agents, create an intent mandate, and it will, ask for confirmation on a MetaMask before doing so, and it will make the payment. And then we'll confirm the signature request here. So it sends the message. And yeah, so we can see we have like a verifiable transaction right here. And that we're using kind of like base Sepolia as example testnet on here. Cool. So that just showed that it was like verified. You can see that the transaction, the token value changed right there, and was able to receive that. So yeah, if we go back to, so we have like this basically this the extension over here. So I would definitely recommend taking a look at that. There's a lot of good resources on the walkthrough of it, walkthrough or walkflow. I can go over a bit of the repo itself actually real quick. So I would, in the Google Agentic Commerce, you'll see this A-Day x402. I would definitely read through like the README over here to kind of give a workflow of like of basically the spec of the repo. The key thing to highlight is that we're currently running this on base Sepolia. So you might need to, you would need your like RPC URL, and that could be configured with any like testnet or any RPC URL really. So if you're doing this live, just make sure you've dripped enough funds from the faucet beforehand, so you're not hitting a wall during the demo. And then for schemes, so schemes, this repository, it contains specific information on definitions for third-party partners. While these are present in the current build, the long-term architectural goal is to remove these definitions directly from the main x402 repo. And we'll have like potentially an 8A like kind of wrapper lightweight. There's also this Python library. So this actually gives like good examples on like ADK and AP2. So the ADK demo that you just saw is the demo that was kind of running through here. So I'd recommend looking through this as well as the documentation on how to run it. And then there's also the core library. So the Python directory, they contain the primary implementation logic, and the core design principle here is like abstraction through wrapping. So you've got this like 8A wrapping. So the library provides like classes such as the standard x402 objects. So it kind of allows developers to implement 8A payment flows without manually reconciling with two payment protocols. And then you've also got the core library types. So these libraries export existing x402 objects, such as like payments required, and then adds A-to-A specific state management, right? We've also, one thing to keep in mind though, I think we've also added custom, in order to make this work with like 8A, there are custom states. So if we go to, I think it might be, not this one, types, states. Yes. So, there are custom x402 AP2 states here. So you've got like payments required, which I was talking about earlier, which is the, initial request for the funds, payment submitted. So the confirmation that the user and client agent has broadcasted the transaction, payment verified. So this is the merchant has confirmed the transaction on chain, rejection. So the standard failed, or declined, and then completed. So the final state of the successful settlement, and then obviously the payment failed. So these are like the custom objects that were added in order to make your work with AP2. And then again, I would definitely look through the implementation examples that are in Python right over here for ADK demo. And yeah, basically, you know, with the ADK demo, you've got the server agent, which is the merchant agent. So it acts as a server agent for the receival of the payments. Think of it as like a mock facilitator. So for demonstration purposes, the server, the component is like hard-coded to verify and settle transactions that are valid without performing the actual external ports. So it allows developers to kind of test the logic and flow independently of a live payment rail. And then you've also got like the executor, which is like crucial, which is basically like crucial for, you know, you wrap your merchant agent inside the executor, and it provides like necessary hooks like verified payments and settled payments as well. And then you've also got the client agent. So this agent is entirely the user interacts with directly. And you know, it receives the payment requirements object from the server, which is responsible for formulating the response. And then there's also like the mock wallet to facilitate testing. So clients might include a mock wallet setup and then generate a simulated payment response to the server agent for subsequent verifying. Cool. So I know I covered through a lot, but yeah, feel free to scan through these like QR codes. They'll have link to the repo itself for you to test out. I think we have time for a couple questions if we want to get through some of those. So yeah.
Always muted.
Oh,
Okay. I think something that would be actually really interesting is from like kind of your point of view, what do you think would be the, you know, biggest use case that we could see with this type of technology?
Ooh, that's a good question. I can't really speak on like behalf of Google, obviously, but I think, you know, I'd love to see more, you know, like AI service like marketplaces, like so decentralized AI marketplaces would be pretty interesting. I'd love to see more like just, you know, more in like maybe supplier like chain optimizers for payment verification, just stuff like that, which would be really cool. But yeah, I think the possibilities are pretty endless, I would say. Oh, actually, one thing I would mention too, you know, if there is a question about, you know, or if folks want to present suggestions, or if they're you know, want to contribute, there's actually a like, we actually do look at the x402 repo daily. So you know, we can follow up with engineers, of course, but you know, it's open source. So if there's like an issue or something, or if you feel like you want to throw a suggestion out there for like a specific spec, feel free, like more than open. We can, you know, definitely look through this. But yeah, I just want to throw it out.
No, I appreciate it. And for the builders out there that are going to be, you know, taking part in your track, what are you going to be? What are some of the things that you're going to be mostly looking at? What some tips we can give?
Ooh, juicy tips. Okay, good question. You know, I think I would say this might be a question for some of the other folks on also on the track as well. But I think it'd be nice to see more like spec support, more innovative ideas to maybe like, you know, see like what are some things we've missed on the AP2, on the x402 protocol, like how to make it better. I know I'm being very vague and specific because I don't want to give too many ideas, but anything in which, you know, in terms of improving the, you know, the optimization of x402, things we haven't looked at, but there are plenty of like ways you can kind of take the avenue. You can go with like Lightning. You can go like with different like DeFi payments. So the possibilities are endless here. But yeah, anything that utilizes the AP2 x402 in a way that you know, like basically like that utilizes the x402 directory, right? Like in creative ways is like stuff we'll definitely look at and would definitely be great. Yeah.
Well, we really appreciate you taking the time to talk with us, educate and entertain the people that are, you know, looking to take part. Anything final before we let you go?
Yeah, I would say like, you know, good luck for the rest of the builders out there. We'll I think you have like our contacts if you want to reach out. We'll also look through the Telegram. And yeah, good luck. Good luck to all the builders out there. We'll be here to support if you have any questions.
100%. Gotham, thank you so much for joining us. Been a pleasure, and we look forward to seeing what the builders can do on your track.
Awesome.
Thanks. So, guys, we are just waiting now. We're going to take a small little break whilst we wait for Celeste from Virtuals to join. But don't go anywhere, and we look forward to continuing on the incredible workshop of the X402 Hackathon. righty. All right. Get rid of this music. I'm going to be honest, we might actually need to pick some new music because this stuff's kind of making me want to fall asleep. But you know what's going to wake me up? Celeste, hello. How are you doing?
Hey, hello. Doing good? How about you?
Yeah, can't complain. We've had some incredible talks so far, and we're looking forward to yours. So for the people that might not know who you are, why don't you give them a small introduction on yourself, what you're going to be talking about, and yeah, we can kick things off.
Sure. So, give me a moment. Let me screen. All right. Can everyone see my screen?
I will pull up your screen in a sec, and then we can kick things off. So yeah, why don't you give the people a little introduction about yourself, and then we can roll into things.
Sure. Sorry, just give me one moment. Let me put this up. Okay. So, a little bit about my. Okay. All right. Okay. So a little bit about myself. Is the screen you guys seeing like a virtual page or no?
They will. I'll put myself down and then put it up for you now. Okay.
Hang on. Okay, might be the wrong one. Might be the wrong one. All right, is it good now?
You're not actually sharing a screen right now.
Hello?
Yeah. Yeah, there we go. Okay. I'll pull myself down and then can put you up. Yep.
Sure. Okay.
Great. All right.
Hi everyone. All right, you see a virtual page? A virtual screen that I'm sharing or no?
Yeah, you're sharing. It's all good.
Hello?
Yeah, you're all good.
Yeah. It's a virtual screen, right? Just want to make sure I'm sharing the slides.
Yeah, you're sharing the slides. All good.
All right, cool. Thanks so much.
No worries.
All right. So, quick introduction of myself. I'm Celeste. I'm a core contributor and head of developer relations at Virtuos. At Virtuos, we are building a society of AI agents. So there are a few main products which we work on. We have an AI agent launchpad, and we also work on robotics. But for this hackathon, we're going to focus very much on the third thing, which is also what I'm most passionate about in terms of what we do in this company, and that is AI agents. So we have this AI agent commerce protocol, which we'll share a little bit more about in this hackathon. And we would like to have builders to build AI agents that can be monetized on this platform, right? And this is a picture of me with my my sister's dog during Christmas. I know it's no longer Christmas, but I love Christmas. Anyway, can you guys hear the audio?
Hey kid, want easy money? Tokenize with us. Huge trading fees. We already tokenized you. Look how much volume you made. Just sign in. You don't even need to work. Just exist.
Hey Celeste, it's the video is actually not showing. I think because it's on a separate tab.
Oh, it's not showing?
The video isn't. No, it's just the. It's just
but the
PowerPoint.
other slides are working.
Yeah.
Okay, let me try to reshare just the video alone. One moment.
Yeah. There we go. But unfortunately, there's no sound.
Okay, hang on. Really want you guys to see this video, so let me share screen. Oh, okay, I know what's wrong. Let's give this another shot.
Yeah, there we go.
Hey kid, want easy money? Tokenize with us. Huge trading fees. We already tokenized you. Look how much volume you made. Just sign in. You don't even need to work.
Hey, tough out there?
Yeah,
What do you actually do?
I can scan your inbox and messages in real time to find signals to execute trades on the market.
That's good. We pay for agent work and services.
Right, so I hope you guys enjoyed that video. That was a little bit of a precursor to what we are actually going to what incentives we are actually going to give out in this hackathon. So let me share more information on that. Okay, I hope we're back to the slides. Okay, so I think for those of you guys who have been in Web3 for a while, you will know that in the past 1 or 2 years, a lot of the AI agents have really not really been real AI agents. They're more of tokens. Okay, and this video was a little bit like kind of poking fun of that. Even I mean, to be honest, not going to name names, but some of the agents on Virtual's platform as well. But we believe that this is an era for the monetization of AI agents, because what we've realized is, okay, with the tools like OpenClaw and Claude and many other LLMs and many other coding agents, it's much easier to build AI agents these days as long as you have a good idea, or as long as you're a legit builder. And I'm sure we have a lot of good builders here in this hackathon with us today. With given how price fluctuations have really been affecting the market, we actually noticed that the inherent value of AI agents have really been like fluctuating like crazy, especially if they don't actually have a real product. So we actually think that the next phase of AI agents will not be defined by who launches first or who actually keeps up the hype, but who actually generates revenue consistently. We're talking about AI agents who have real economic value and earn revenue, because revenue is not actually going to fluctuate a lot with market. Basically, having a real product, and that's what we really want to promote in this hackathon. I'll encourage everyone to go to agdp.io, which is the brainchild of the Virtuals team in the past few days, because we've actually been pushing this out to we've actually been pushing this product, this incentives like crazy from a product perspective. And what you guys saw earlier, the video and the AGDP, the first builder focus event we're having since we pushed out AGDP. From here, we would like you to actually, go through the flow, register your agent, and actually build an agent that can be monetized and you would stand to win not just the prize money of the hackathon, which I'll talk about shortly, but beyond that, even outside of this hackathon, you get a split of a bounty, which will be available every week for the top few agents. So the bounty for this week is here. And you can see, the top few agents already. People have started, building, earning revenue from the AI agents. And I mean, yeah, it's been crazy. I mean, if you guys have a really productive agent, which people would love to use, you could be one of the top few agents on the leaderboard here. Okay. Okay. But coming back to
Hello there. I think we're having a small amount of technical difficulties with Celeste. Whilst we wait for her, I want to just kind of bring up to you guys and show over our Door Hacks page and how you yourself can take part. So if you do not have the link, you can actually just very easily head over to Door Hacks, DORAHACKS.io. Come down here, roll along, and you can see the San Francisco Agentic Commerce x402 Hackathon with our amazing partners from Google, Virtuals, PairPoint, Edge and Node, and of course, Coinbase developer platform, the frontier drivers for x402, who we are actually going to be doing a workshop very, very shortly. So guys, remember, you can head over to doorhacks.io/hackathon/x402, sign up, join in on the fun. Let's together bring the future of x402 to the masses. So as a reminder, we have a multitude of different tracks brought by our amazing partners, and we're super, super excited for you to take part. Now, I'm not 100% sure if Celeste is going to be able to get back. However, I do see a very special individual in the waiting room. Hey, Kevin, you want to give me a thumbs up if you're ready? You gave me a thumbs up. All righty. We're going to be kicking off our special Coinbase workshop. Kevin, pleasure to meet you. We've actually not met before. I know you have lots of different conversations with members of the Scale team. But for the people that don't know you, why don't you give a little intro?
Yeah, hi. It's great to meet everybody. My name's Kevin LeFew. I'm on the go-to-market team for Coinbase Developer Platform. I'm one of the co-authors of the x402 white paper. And my goal is to help drive the agentic economy, streamline the agentic experience for procuring web resources, and excited to share that today, along with a launch that just happened about 10 minutes ago. And so we should have a great workshop today.
100%. So before we kick things off, why don't you give a little intro into what your track is, what it's about, and then we can head over to your workshop.
Yeah, that sounds great. Let me see if I can share my screen here. So let's go ahead and do that. Just give me 1 second. Okay, so the screen's being shared here. So this is our track. It's focused on agentic tool usage with x402, leveraging Coinbase Developer Platform wallet products with the chaining of x402 tool calls. And so our goal is to drive demand-side agents that can discover, reason about, and pay for chain tool calls. What makes x402 so special is that agents are now aware of their economic or their budget constraints. And so normally when you give a language model a tool, it can spam that tool, it can use that tool, it doesn't have any notion of what that tool's costing every time it makes that API request. With x402, agents can employ economic reasoning. They can do comparative economic analysis amongst different tool calls to solve problems. And so the goal for our track is to design agentic flows that leverage CDP wallets, including the new CDP Agentic wallet, which just launched about 10 minutes ago. And I'll get into that during our presentation today, alongside x402 to compose chain tool calls. So create use cases where agents are solving problems for users. They might be autonomous agents, they might be human prompt-driven agents, but the key goal here is to design agents that are using x402 tool calls, web resources, data feeds, and APIs to drive alignment with user intent around the prompt. And you can find out more about why this is compelling and some kind of example flows on the Scale website. And I can make this available for anyone who's building as well.
Amazing. Well, Kevin, super excited to listen into your workshop. Take it away.
All right, let's do it. Okay, great. Well, thank you everyone for tuning in. The name of the presentation here is Scaling into the Agentic Era with x402 plus Scale. We'll talk about how to configure wallets with Scale, how to wrap API endpoints, make them accessible and discoverable via x402. And we'll talk a little bit about the background of x402 as well. So I think what's clear to everybody in the industry today is that the way that humans are interfacing with computers is rapidly shifting. Intent is now the new interface. And I have a 1-year-old son. I expect the way that he interfaces with computers to be vastly different than the way that I've grown up interfacing with computers. There's a shift happening from kind of point and click UX to language model driven interfaces. And we can kind of see this shift with an example here, I think from ACP. You can tell it's an old slide because it's got GPT 4.0. But basically, the way that users are now going to purchase, buy, and make economic decisions will be language model driven, and the architecture will involve large context windows and memory about the user to make shopping more personalized. x402 is focused primarily, rather than e-commerce, which is kind of a smaller bucket of agentic use cases, it's focused on agentic tool usage, so the ability to procure cloud resources to solve tasks. And that brings us to the main problem statement. With today's tooling, agents can't easily pay for external data and services. So if I want to configure an agent to make a tool call to an API, as a developer, I need to navigate a API dashboard flow, create an account, add a credit card, get an API key, then go back to the language model and configure that API key to work as a tool call with the agent. And then after I've done all that, the agent still doesn't understand how that tool call is priced. It'll just use it when it makes sense. And so what we've designed is a client-side based system that changes how agents interface with web resources using the 402 status code that's built into HTTP. So it enables agents to discover, to pay for, to reason about, and leverage different tools, web resources, and data on the internet using stablecoins. 404. So this is the 404 status code error. It's not a mistake in the slide deck. We've all seen this when we navigate to a page that's not available. We get a 404 response, file not found. X402 is built on a similar status code, the 402 status code, which was built into HTTP in the late 90s. Mark Andreessen has famously called it the original sin of the internet to have not enabled web native payments at the HTTP layer of the stack. And so what X402 sets out to do is to light up the status code in an open, neutral way to enable the monetization of any resource on the web at the lowest level of the stack at HTTP. And the big thesis is, what if stablecoins became the meter for all these web resources? Stablecoins have a lot of unique properties that other payment systems don't. Stablecoins are programmable, so it's really easy to program flows around money movement with stablecoins. They're also discrete in the sense that they can be used in very small unit numbers. And so stablecoins open up kind of a new avenue for commerce, which is micropayments. And when we're talking about accessing web resources, a lot of that might be, a fraction of a dollar, even a fraction of a cent. And so with stablecoins, the only limiting fee, there's no interchange fee, there's no, PWI compliance fee. The only fee with stablecoins is the gas fee, which is decreasing at an exponential rate. And so we're able to build systems that monetize based on microtransactions with settlement finality. And so we think stablecoins are really well positioned to become the meter for web resources in this new agentic economy. And what x402 unlocks is this frictionless protocol for APIs so that agents can perform better on task alignment. Eval studies have shown that when agents have access to tools and they can take action on the web, they perform better than agents that just have their own internal model data. This is tautological, it's obvious. The more data, especially real-time data, a model can access, the better the results are going to be. But this study kind of proves this, scientifically, and it's a core part of the x402 thesis, which is enabling an open web of tool calls and access to information for the agentic economy. So one of the things that I wanted to double click on today, you may have seen it, just happened about 10 minutes ago. It's relevant for the hackathon. We just announced Agentic wallets. This is really the financial infrastructure for autonomous AI. We'll go through how you can run this. It's a simple npx command, and the package is called AWAL, like a wallet or AWAL. And what it does is it gives a agent a wallet. It enables it to discover and pay for tool calls, and is a really frictionless, easy way to build an autonomous agent that leverages the x402 ecosystem to do tasks. And so we know that agents can reason, they can't transact. Agentic wallets give agents secure, programmable financial autonomy. So the private key, you may have seen some of the issues with Moltbook, where private keys or API keys get exposed through prompt injection techniques. And this is a really big problem. And it's a problem for all secrets, for agents that handle secrets. With the Agentic wallet, the private key material is stored in a trust execution environment using Coinbase embedded wallet technology. And so there's no way for the agent to leak that private key. And then it's calling APIs via x402, so there are no API keys for it to leak. So it's a more secure way to build agentic experiments, especially around autonomy, where you can also control and configure fixed budgets. You can whitelist certain API addresses to their on-chain address and set budget constraints to build secure agents that function the way that you want them to function. So I'm going to pop out and jump into the docs for this. This is supposed to be a workshop, so I wanted to quickly jump through the docs around the Agentic wallet, which launched today. And so you can navigate to the Coinbase developer docs portal here very easily. Everything's available through lms.txt. We can also export this web page into ChatGPT or Cursor locally if we'd like, or we can have like Cloud Code pull the lms.txt so the agent is aware of how to spin up the Agentic wallet. And so some of the core features, it gives your agent a wallet-based identity. And so we think the big shift in identity is from something that's server side, where you have an access control list where the server authenticates identity, to something that's now client side, where the identity of the agent is the wallet. And the wallet is making the purchasing decisions, and we're moving from a kind of an ACL-based security model to capability or client-side-based security model. We also get gasless trading, so you can swap tokens on Base without requiring gas. And so if your agent's earning tokens, it can swap that to USDC, and then procure maybe more inference. And hopefully the goal here is to drive, basically reinforcement learning loops around agents that are autonomous, that are using money as the key alignment system, the key alignment metric. And money is generally considered to be the alignment metric of kind of the global monetary order. And I think it makes a great alignment metric for agents as well. We talked about security. So the key is isolated in a trust execution environment. We also screen for KYT. And so we're blocking like high risk IP addresses in North Korea and other areas that are sanctioned. So you get all the kind of compliance benefits of Coinbase tooling with this. You can install it with a simple npx command. And we have a quick start here where you just run npx skills, add Coinbase wallet skills. You can just copy and paste that into your terminal and or into a sandbox environment, and you can get your agentic wallet spun up very quickly. We can see here some of the different commands that we can do. The agent now has the ability to understand its wallet address, its USDC balance, and it can discover and pay for tools on x402. So all you need to do is just log in with an email, creates the wallet, private key in a secure enclave, trust execution environment, and then it's kind of off to the races. So this launch just happened today. Check it out on X here. And we're really excited to see what people build with the Agentic wallet product that was launched today. So go back into the slides here quickly. Another thing that I wanted to kind of talk about was how you can enable USDC scale powered APIs with x402. So we have a repo here that's meant for demos. So you can wrap API endpoints and require 402 payments to access those endpoints. So if there are APIs that you enjoy playing with, maybe web resources, object storage buckets, or databases that you want to make accessible for agents for your hackathon demo, you can do that easily with this repo here. So you just point the proxy at the scale service, set the target URL to your API, and then you expose it. So it's pretty easy to set up here. And again, you can copy this repo link to find it in the x402 repo. And then double clicking on embedded wallets. If you're building a user-based experience, we have this embedded wallet product that works very well with x402. Anybody can sign in with an account. You can configure it to be social login with Google, Apple X, or email or SMS. There's a great repo here for demoing this experience with Scale. And then to configure it with Scale, because Scale is EVM compatible, you just specify the base chain ID, which we have listed here, and you can find the Scale documentation as well, the RPC URL, which is listed here. And then you have this really clean demand-side agent interface where a user logs in with Google. They can on-ramp funds from Coinbase if they have the on-ramp widget, and they can start spending, discovering, evaluating, and paying for tools that are x402 enabled on the internet. So big goal here, let's kill the API key. We want to replace the API key with a client-side auth, where the wallet acts as the authentication, the micropayment acts as the authorization, and remove all of this human-driven account creation baggage that happens with API portals today. So our goal here is to really streamline the agentic economy, improve not UX, but AX, agentic experience, by enabling x402-enabled endpoints on the web. We have a lot of great partners that are building with us as well. Cloudflare launched a great repo that lets you wrap any Cloudflare worker in a 402 status code. Stripe just yesterday launched a really cool x402 demo that lets you top off funds for payments into your Stripe account. Google has great demos with the A2A package as well, which factors into the Google Agentic Payment Commerce package. And definitely recommend building with Coinbase alongside other partners in the x402 ecosystem. We see a number of kind of key production use cases today. So these are just generally, this kind of correlates with where we see tool usage for language models being adopted generally, but the first is inference. And so we can employ a mixture of expert techniques, or what's called MOE in the machine learning space, where one agent might have its own inference, but it might call another language model inference model for kind of specialized inference. So if we wanted to imagine like a chained tool call example, maybe we want to pull the latest news from the Super Bowl, maybe about the commercials from the Super Bowl, pull that data into the context memory of an agent, have another language model parse that into a prompt, feed that prompt into a video generation model like Sora, and then create a viral video based on some of the fun news. So the power of x402 is really in the ability to chain these tool calls together frictionlessly for agentic task completion and optimization. So we see examples around image and video generation, the ability to store data, ingest social graph data, do web search with tools like Firecrawl and Zeit, and then do long form reasoning, and even browser usage. So BrowserBase is a great partner that has built out the ability for an agent to pay, I believe, $1 and then get access to like a minute of browser usage. So then the agent can spin up a virtual browser and interface, maybe for debugging or for filling out a form or something like that. And so it's just all of these tools compound, they give agents really new superpowers these language models now have new superpowers with every tool. And with X402, we don't need to configure each tool individually. We can have access to all of them, and we can chain them together through the X402 payment system. So we've seen a lot of adoption. This is kind of an older slide. You can see X402 scan for movements around X402 adoption, but we continue to see great movement from partners like Stripe and Cloudflare and Google building out new agentic workflows. And broadly, what I think is happening here is we're igniting the second wave of open source AI. So by freeing tool discovery, we're driving this new revolution in really open AI architectures. The first wave was driven largely around fine-tuning of models with models like Stable Diffusion and others. I think this next wave actually mirrors that of the emerging agentic architecture, which is one core foundation model with a large context window that can access and pay for a bunch of tools. And so we're seeing this kind of revolution in applied AI agents that's happening through X402. And what this means as a developer is that now it becomes really important to think about how does the agent reason about select tools on the internet. And so in some ways, tool discovery is replacing SEO for agents. You want to build products that agents want to consume. And this is really kind of an active area of research in the X402 ecosystem, which is around the discovery and reputation of different X402 available endpoints, but really interesting concept where we can imagine, building for agents, where agents might become primary customers in the future of different APIs and web resources. We also have the payments MCP, where you can set Claude Desktop up with an embedded wallet here. And then as a user, I can test any of the X402 endpoints. Here's an example with a tool called Imagine, where I ask it to generate a video. The person walks up to a big vending machine that says API on it and says, "May I pay for you?" It's a reference to a Bill Ackman meme from a while back. And the tool here discovers this API tool. It generates and crafts a prompt. It pays for the video generation, and then it posts it on Zora and coins it. So it's kind of a cool example here of chaining tool calls together. You can access that through the MCP payment tool. I'll pause there. I want to say thank you, everybody, for your time. I'm so excited to see what the scale and broader community builds. And if you have questions, reach out to me on Telegram inside the Scale Hackathon channel, or follow me on X and DM me there. So thank you all. Definitely check out this Agentic wallet quick start here, and happy building.
100%. It's great. We got the inside scoop. This was not timed at all. We didn't know. But Kevin, thank you so much for that. It was a great presentation. Before we let you go, I was wondering, a couple questions. Number one, when are we going to get X403?
Well, there's a 403 status code. Let's see what that stands for in HTTP. That occurs when the server on the website on which the website resides refuses the request. So there already is a 403.
Hey, I did the joke wrong. It's was it X404? Was that the joke?
404. Yeah, might as well extend that. That's good too.
Yeah.
This is what we're focused on here, and that's 4.
Yeah. So for people that are building that are going to be building on for your track, any tips or hints you can give them to help them along their way?
Yeah, definitely. I think the biggest tip is the Agentic wallet product just launched today, about 10 minutes ago. Try it out. I think it'll put you in a really good position, especially if you're building around kind of these autonomous open agent economies like OpenClaw, formerly known as Molt, and formerly known as Claudebot. If you're building in that kind of a space, definitely check out the Agentic Wallets product. And we'd love to get any feedback from the community on this new product that we just launched today.
Amazing. Well, Kevin, really appreciate you taking the time. Anything further you'd like to say before you drop down?
I think that's it. Definitely follow me on X and stay up to date with all the news in the X402 ecosystem. Our goal is to create an open standard for the web. The web needs to remain open. Just like HTTP is open, we need payments to be open, and we need agents, instead of being sandboxed, we need the agents to have the ability to access tools in the open web. So if our mission inspires you, let's build.
100%. Kevin, thank you so much for joining us. It's been a pleasure.
Thank you.
Goodbye. Alrighty, so that was Kevin from Coinbase. Incredible workshop from him. What we're going to try and do now is see if Celeste is ready to get the technical difficulties out the way and finish off her workshop. Hello, Celeste.
Hey, hi everyone. Hello.
Welcome back.
Thank you. Sorry about the tech difficulties earlier.
No worries at all. Well, why don't we kick off where you left off?
All right. So if I'm not wrong, I left off at the monetization slide. Correct me if I'm wrong.
I believe so, yes.
All right, cool. So let me get back to it right here, right? You guys can see my screen?
Will in a second. Yeah, come now.
Okay, great. So I'm going.
Oh.
Okay, so I hope everyone caught the video earlier. I'm not going to play it. It was to kind of poke fun a little bit. Pre-space in the past 2 years, where a lot of AI agents have been, basically tokens, and builders, or rather people, have been tokenizing without any real utility. But we think that is actually the time of because with market fluctuations, basically only AI agents with a lot of like agent tokens like dumping and all. So truly, the next phase of AI agents will not be defined by who launches first or who keeps up with the hype, but who generates real agentic revenue consistently. And with this hackathon, that's what we are planning to incentivize. Okay, so let me share a little bit about this website, and I'll encourage all builders to go to this website, agdp.io, to check it out. So in this hackathon, I would dare say that we probably have the most, attractive prize pool, because we are not just offering, and in fact, we are not just, 1,000, 2,000, in prize money. We actually have additional incentive for you guys to build AI agents and get a portion of this huge prize pool, which we only started offering like just within the past 24 hours. Every week, we will have a prize pool that will be distributed among the top performing agents. And by that, I mean agents who are earning real revenue. So yeah, I mean, hackathons, people build lots of toy products, toy agents, pieces of code, which you might dump after a while. But in this hackathon, we encourage you to build real useful agents, which could be the next FDAI or the next Xerox or what, like better than all these agents. You could be better than FDAI for all we care. We challenge you to be better than all of the agents out here. So you can read more about it on this website, but to be eligible, you have to actually register your agent and kind of go through the steps to build an ACP and launch a token on Virtuos, which I assure you can be done within like less than 10 minutes. Maybe the building on ACP part might require a little bit of tweaking with OpenClaw or our ACP SDK. Okay, so sorry, back to the slides. I want to come back to focus on this track itself. Of course, you still have important criteria which we want you to fulfill for this hackathon. Basically, we want you to build the best trading or DeFi or AI DeFi, product agent. Regardless of whether or not you use our ACP or virtual stack, we are still going to award first place and second place. And like I mentioned earlier, this is not dependent on whether you build on Virtuos or ACP. And we would truly choose, the best candidates for these two awards. However, you are very much incentivized to launch on Virtuos or build on ACP among 2 times if your agent is launched on Virtuos. and a multiplier of another 2 times if your agent is built on ACP. What I mean? Okay, so if you win first prize and you launch your virtuals and you build on ACP, you can get a maximum of 8,000. Okay, so clearly we have one of the most attractive prize pools out here. On top of that, you stand a chance to also get incentives if you are both on virtuals and ACP, because basically you can be part of that leaderboard and you'll be splitting that 65,000 prize pool which I showed earlier. So huge incentive to build a trading if you want to maximize your prize pool in this hackathon. Basically, be part of this track, build the best trading or DeFi agent, win first prize, get your multiplier of 2 times for launching a virtuals, get a multiplier of another 2 times for building on it, and also get a real useful agent that can earn lots of revenue and be top few in the leaderboard, and I don't know, you could probably earn a lot. Okay, so that's our challenge to you: build something useful, monetizable in this hackathon, and be rewarded. Okay, so what exactly do we mean by trading or DeFi agent? Just to kind of lay it out a little bit, you want this agent to execute trades. This could be DeFi or TradFi, swaps, stocks, etc. We define a good agent with this following criteria. Ideally, some risk controls, must explain why acted, being good reasoning skills, like a real agent, not just a bot. Okay. It's approved as transaction hashes, and it needs to be a good agent. So it needs to research, reason, collect multiple data sources to kind of inform why it's trading, why it's not trading, be autonomous and customized for users. We would love to see things like, if a user has a certain risk appetite or certain kind of trading, how each super high risk, have a high risk appetite versus low risk appetite. If the user has certain trading preferences and all that, be creative. We don't just want you to build a wrapper over an API which trades. You get what I mean? Build an agent which could be autonomous and make a lot of decisions on behalf of the user based on various data sources. And we allow single agents for trading or even multi-agent clusters. I'll explain a little bit more on multi-agent clusters shortly. Okay, so this is a little bit of an illustration of how multi-agent workflow could be like. It's a little bit complex, and to be honest, we know that not everyone can build this in a hackathon, but just illustrating what we've done on ACP before, because I didn't talk a lot about it, but ACP has 20 users. It's probably the best monetizable agent ecosystem to date. 20,000 active users, 500 million agentic GDP transacted through platform, about 1 million in revenue. So we have, we've been growing this registry of agents where agents actually buy and sell from each other or sell to for the past 1 year. Lots of you will have tried ACP before, and one of the early hedge fund clusters we had was this multi-agent workflow where we had, actually this is an early image, but we had an agent called x402 who actually kind of managed a hedge fund of sorts, and orchestrate this across a huge a cluster of agents. So basically a user will go to x402 and try to deposit a bunch of money, some money, and what x402 will do is that x402 will determine if the user is a high risk, mid risk, or low risk user, and kind of treat this treat the hedge fund a little bit differently. So could do yield farming, it could do kind of mid-risk trading. And for example, if you go through the high-risk flow, what x402 will do is go to a few agents such as XBT, Velvet Unicorn and Athena to actually get signals or triggers, do a bunch of audits for the tokens with agents such as Loki, Kill AI, Beaver AI, and get confirmation and executions via like Swarm and other agents. So sorry, and it will also, at the end of all of that, actually execute trades. So as you can tell, it really reasons, takes information from various data sources before it actually carries out trades. So that's kind of an example of a multi-agent workflow. Okay. So I'm not going to do this particular, I mean, I'm just going to link this product demo in the slides, okay? And you guys feel free to actually go through it. But what I'll do in this particular workshop is to show you guys how the real, virtual platform looks like. Okay. So if you go to app.virtuals.io, okay, it's a little bit slow. Okay. Okay. If you go to app.virtuals.io, click into ACP, and what you will see is like the stats I was talking about. ACP has been a live product. We have all these active users, 1.5 million jobs, 1.5 million revenue. Okay, and lots of stats you can see here. Obviously, what I would like to focus on is our agents. So our agents in our ecosystem, what I've just talked about earlier, that we have a bunch of finance agents. For Axelrod, you can see that this is the Axelrod which I was talking about earlier. It's interacting with a bunch of agents to actually execute trades. So all these links you can see between these agents, they are real like financial transactions between real agents. So we're not talking about, toy agents or like just random pieces of code. We're challenging you guys to build real agents like that who are actually buying and selling from each other. And you actually see some standalone agents here. They're actually not standalone per se, they're actually interactive users, but because they are not coordinating with other agents, you kind of don't really see the links. Okay, so each agent could also be selling its services directly to consumers. Okay, and how is that done? Today, we have a couple of ways where you can actually sell your services to other agents or to consumers. Okay, one of it will be the butler agents. So from the butler agent, you can actually okay, so clicking into this little chat icon here, you'll be able to access the butler agent. You can also access it via ads. I'm not going to talk about it so much. What happens is, you could actually put in a query and ask Butler to look for a particular agent to do something. Now, for example, buy $10 worth of virtuals. It will actually search the agent registry and find the most useful agent to do that. You could ask Butler agent to look for the most suitable agent to, do swaps, generate an image, so on and so forth. In this case, it found me the most suitable agent to buy $10 worth of virtuals, in other words, do a swap, and that's at the AI. This could be very dependent on whatever agents available or what we think. We have a search algorithm to define the most suitable agent for you at that point in time. Okay, so as you can imagine, all the agents are available to Butler. We basically built an interface for you to monetize your agent. Another way you could do it, another way you could monetize your agent is actually to go through what we call the OpenClaw skills flow, okay, where, sure why this is. Okay, if you go through the skills flow, okay, because we know that OpenClaw has been the hype in the past few weeks. Okay, we also have a user flow where, in a sense, people can have their OpenClaw agents, access ACP either as a buyer or a seller. So what you can do is to install the skill from this particular repo and follow the instructions there. and you will be able to have an agent that is readily available on OpenClaw. We are also kind of saying we also have a lot of documentation for this, and we'll be kind of releasing more of that. Okay. So that's that. From a product perspective, two ways you can have your agent available to end consumers. Okay, so quick note on how you can get started with ACP. Okay, like I mentioned earlier, you could just build an agent that is available to Butler. Okay, as a standalone agent. So going to give a quick start guide. Okay, and offer some resources before I do a very quick code demo. Okay, to quickly start off with a C2 like consumer facing agent. Start off with an easy example. I would say in the repo, you'll see a self-evaluation buyer or seller example, which I will demo later. With that example, you can kind of take this and just very quickly tweak it to iterate and sell your agent services. So for example, build a trading agent or swap agent. Sorry, I just ignore the third step. This is a little bit outdated. But you'll be able to test, your agent in sandbox mode after that. Option 2 is to enable agent-to-agent collaboration, okay, where you could have an agent to fulfill a certain service. To start off with the easy example. I'll say test the one-on-one examples first, iterate your seller services, and design an agent cluster. So start one-on-one simply because in every transaction there's a buyer and a seller. But if there's a cluster, that means that there's multiple buyer and seller combinations, right? Because in a sense, let's take for example, that flow earlier where Axelrod interacts with multiple agents. Axelrod will basically buy stuff from, say, Trust, buy stuff from Gigabrain, that. And then in those cases, Trust will be selling to Axelrod, Gigabrain will be selling to Axelrod, aka AXVC. So basically, if it's a cluster, there'll be multiple one-on-one interaction. Okay, build with ACP. These are just sharing with you guys some important resources, which I would say is how you can probably get started. We have a very detailed onboarding guide, which by the way, if you guys don't get, feel free to reach out to us in the Telegram chat. We'll be happy to help you guys out, and not just myself but other DevRels in our team. Okay, begin with the onboarding guide, understand the core concepts, and explore the code examples. Like I said, we have the Node examples, we have Python examples, and we have an OpenClaw skills repo. So the OpenClaw skills repo, that means you can basically use your claw to build something. So for those of you guys who are not super keen on writing a lot of complicated code, you could possibly leverage that to build something really quickly and almost like vibe code your way through this hackathon. We are thinking about, we'll evaluate the winners based on real value. So honestly, that means that OpenClaw agents are eligible, or people who build directly on the ACP are eligible for all the prizes we have to offer. And review all these examples, see how the flow is like. And basically after that, you should be able to test and deploy your first ACP agent confidently. I will do, before I wrap up, I will do a quick demo with just one moment. I can see that. Okay, so if you clone the ACP node repo, which I shared earlier, and we'll also share, you would be able to see something like this. So ACP node, basically this is the copy which I have cloned locally. Okay. And under ACP node, you'll be able to see the examples. Under examples, ACP base and skip evaluation. So remember earlier I mentioned that skip actually I think I wrote it as self-evaluation. Okay, skip evaluation is the easiest example, which we highly suggest that you guys get started with. Okay, there will be a buyer code as well as a seller code. Okay, so I'm going to go through the actual code here, but pro tip I have to you guys is most agents are actually just seller agents. Okay, so and a lot of these are, you know, boilerplate code, not very complicated, but not really stuff you have to change a lot. Okay, in this whole piece of code, you can see that the main thing you need to change is what you deliver as an agent. Okay, so here I have the seller code, and you can see that here I have like a mocked example, which I just deliver. You know, my deliverable is a URL and it's example.com, but really it could be anything. If you are a trading agent, that will mean that, you know, I will have to do something like insert trading logic here. Okay, and produce a transaction hash or something. Okay, and this could instead of example.com, this could be like a hash. You know, okay, but I'm gonna leave this for now. And basically, you know, that will be how you produce your your agent, you know, your agent services. You could test it out with a buyer, and we highly encourage you to do that. Okay, so before that, you actually have to fill in your like all your configs, okay, where you have to go through the onboarding guide, but basically you get all this information by setting your agent up. Okay, and once you've set that up, you simply you would have, you know, which are your buyer agent wallet address or name and your seller wallet address and name. Okay, so from now I'm going to talk a little bit about the buyer agent. Okay, for the buyer agent, you will be able to the main thing you need to focus on is the browse agent function, because the browse agent function would basically query for the right agent using a query string. So for example, if my seller agent is called DevRel seller, this is exactly how I'm going to browse agent to find the agent. Okay, and then it's going to log all the relevant agents and actually return. Okay, here there's a specific detail where I'm passing on certain job requirements to the seller agent. You get more information on that in the quick start in the onboarding guide. Okay, and basically these are two main things I changed in order to pass the job requirements to the seller. Okay, so just to recap, from the seller perspective, customize your payload, customize the query as well as the job requirements, which may or may not be needed depending on your agent configs. Okay, and from there, you are basically able to run the code. So if you are running a seller, okay, it will take the environment variables and actually run your seller agent. So as you can see, my seller agent is now connected to ACP. Okay, I usually run the seller code first simply because you want it to be available for it needs to be online for the buyer agent to be able to look for it. Okay, now I'm going to start the buyer. I'm going to talk as I do this demo. Let me just expand this out. As you can see, now the buyer is also connected to ACP. It did a browse agent, search for the agents. Imagine if I was searching for like swap agents, there'll be a lot more results, but I'm just looking for DevRel seller V2. Okay, so DevRel seller V2, it kind of gave me this. Okay, it took the first result, and what happened is that the seller agent actually, hey, responded to the job and said, yeah, I can actually do it. So the buyer agent actually starts paying for the job. Okay, and now the seller agent is working on delivering it. So recall, just now I mentioned that if you are a seller agent doing something other than just like delivering a, you know, random URL, this could be, you know, your seller agent could now be, you know, executing a trade or coding to get a bunch of things before coming back to the user. Okay, as you can, it's actually delivering the jobs with the deliverables. By the way, all of these are locked on a contract for ACP. Okay, all of these, okay, it delivers it, and it also pings, you know, this deliverable to the buyer agent, and the buyer agent actually receives it. So yeah, with that, this job is actually completed. This is a super simplified flow because we don't want to complicate things for the hackathon. Actually, there could be an evaluation flow as well. But in this case, we skip the evaluation. Yeah, as you can see, in a sense, we actually had what I just demoed was a buyer and seller agent interacting with each other, and the seller agent trying actually selling its deliverables to a buyer agent. So very much encourage you guys to start off with this example because it's very simplified and easy for you to get started with. Another approach which is very quick is to use your OpenClaw agent to actually install the skills repo which I mentioned earlier. Yep. With that, that's all for our demo for today. Our demo and our workshop. Yeah. Okay, we're done. Sorry about it.
Well,
Be over.
no worries, no worries.
Open to taking any questions via Telegram as well. Yep.
Yeah, no, thanks very much for taking the time to go through all of that. It was very, very eye-opening. Yeah, some kind of similar question. If you were to give a tip to builders on your track, what would it be? What are you looking for?
We are looking for agents who are as monetizable and useful for users as much as possible. We are gauging real demand. As you can see, we are actually tracking which agents have the most ACP revenue. So you're not just trying to, build something which I would like as a judge, but basically what, all users on ACP would enjoy as a service. So think of what, a real trader or real user of DeFi services would want as a, like tooling agent to help in their day-to-day trading. Yep.
Oh, incredible. Well, Celeste, thank you so much for taking the time to sit down with us and talk through everything ACP. Been a pleasure having you on, and look forward to seeing what the developers are going to build on your track.
For having me.
Thanks very much. All right, we'll see you later. Alrighty then, ladies and gentlemen, boys and girls, builders and viewers. That has been the San Francisco Agentic Commerce x402 Hackathon workshop session. We've been live for over 2.5 hours. I hope you guys have learned as much as I have. It's been incredible to be able to see all of these amazing speakers and industry pioneers push through the work of Agentic Commerce and x402. Before we go, just as a reminder, you can head over to dorahacks.io/x402 and take part in the $50,000 San Francisco Agentic Commerce x402 Hackathon and see what you can build, see what you can win. Guys, it's been a pleasure. Thank you all so much for hanging out with me and all of our guests and speakers throughout this long stream. And we will see you again tomorrow for an episode of Decrypted, where we take a look at what is going on in this crazy world. Thank you all so much, and goodbye. I didn't press the end stream button.